Willman Education. Welcome, dear learners. Today I am going to teach you the simple machines, which is part of physics for secondary schools. Machines make our work easier. Tools and objects that help us to perform the same amount of work with much less effort than if we do the work manually are called machines. Because in our everyday life we have to do a lot of work. So machines are important. Tools such as spoons, knives, hammers are called the simple machines. The functioning
Let
of
us see
machines.
how a machine utilizes the force applied on it
Changing
in different
the
ways to
magnitude
make our
of
work
applied
easier.
force.
Number 1. Changing the magnitude of applied force. It is very difficult to open the sealed metal cap of a cold drink
This type
bottle
machines
with our bare hands. However, a bottle
force
opener
multiplier
multiplies the applied force or the effort
Changing
applied on it, and hence much less
direction
effort is required to open
of
the cap.
applied force.
Such type of machines are called the force multiplier machines. Now changing the direction of the applied force. The machines which from where we draw the water, underground water, so that is also direction change that way. So it helps. Now, mechanical advantage of a machine, the factor by which a machine multiplies the force applied is called mechanical advantage. The force applied on the machine to do some work is called effort. The force applied by the machine on the object is called the load. Factors by which a machine multiplies the force applied is called mechanical advantage. So, mechanical advantage MA equals to load by effort. The mechanical advantage of a machine is the ratio of the load to the effort. Applied force on the machine to do some work is called effort. The force applied by machine on the object is called load. So we come to know the mechanical advantage, we come to know about the effort, we come to know about the load. So mechanical advantage MA equals to load by effort, that is already told. So let us see in what way mechanical advantage helps us. So greater the mechanical advantage of a machine, smaller is the effort required to lift the given load. If effort is less than load, then mechanical advantage is more than 1. If effort is more than load, then mechanical advantage is less than 1. If effort equals to load, then mechanical advantage equals to 1. Efficiency of a machine. Efficiency of a machine depends on the work done by the machine and the work done on the machine. So when we want to find out the efficiency, we calculate output energy and divided by input energy. So work done by the machine divided by work done on the machine. So efficiency percentage, output energy by input energy into 100, that is the percentage 100. Then we can easily calculate the efficiency of a machine in percentage. Then the types of simple machines. Simple machines can be classified into the 6 main types: the lever, number 1, number 2 inclined plane, number 3 wedge, number 4 screw, number 5 pulley, number 6 wheel and axle. So altogether there are 6 simple machines we are coming to know over here. Number 1, lever. Lever is the simplest of all types of machines. A lever is a rigid bar that can rotate freely about a point. The fixed point about which the lever can rotate is called fulcrum. and the object to be lifted or moved with the help of the lever is called load, and therefore the force applied on the lever is called the effort. The product of the load and the load arm is always equal to the product of the effort and the effort arm. Principle of a lever. Here we will come to know about the load into load arm equals to effort into effort arm. Again, load divided by effort equals to effort arm divided by load arm. So this is the principle of a lever that states the product of the load and the load arm is always equal to the product of the effort and the effort arm. So on the basis of the relative positions of load, effort and fulcrum, lever is classified as first class lever, second class lever and third class lever. Sometimes we call it class 1 lever, class 2 lever, class 3 lever. So now we are coming to know what is lever number 1. Basic parts of a lever. Over here you can see fulcrum is in between, and here load and effort on the two ends. So first class lever actually, though these are the part. So first class lever or the class 1 lever, in this lever the fulcrum located between the load and the effort. Here is a diagrammatic presentation through which you can keep in mind that first class lever, pliers, seesaw, beam balance, crowbar, pairs of scissors are all examples of first class lever or the class 1 lever. So here is the beautiful drawing, a picture of a pliers. Load in one end, effort is another end, fulcrum is in between. So that is why it is called first class lever. Remember that the first class lever always takes the fulcrum in between. Then here is second class lever. Fulcrum is in one end, load is in the middle and effort is another end. In this type of lever, the load lies between the effort and the fulcrum. Examples of second class lever are nutcrackers, bottle openers, paper. Third class lever or the class 3 levers. Here you will come to know about the class 3 lever. Fulcrum is one end, load is another end and effort is in between. So human forearm is also the best example of it. So here in this lever the effort lies between the load and the fulcrum. Here the diagrammatical presentation of fulcrum, effort and load. Examples are human forearms, fishing rod, tongs, forceps and the fire tongs. These are the examples. Now we come to know about inclined plane. Inclined planes are very important, though it is a wooden plank. You can see over here, this diagram shows very clearly that how a heavy object is being lifted on a height, certain height. Maybe it is a mini truck or van, whatever. So that is the thing. So formation of inclined plane, you can see a wooden plank and one is a quite high block. How we are just turning it into inclined plane, how we form it. So this is the way we form inclined plane. So then easily we can, with a less effort, we can easily lift the object. Now we are coming to know about the wedge. So here wedge is a very simple principles of wedge. Wedge is a double inclined plane such that the two sloping surfaces taper to form a sharp edge. The sharp edge is used to cut, slice or push things apart. A knife, an axle, a chisel are some examples of wedges which are used commonly. Here you can see the chisel and the axe. This is the example of the wedge. Now you see the screw. Screw is also a very Good example of the simple machines. A screw is a cylindrical rod marked with a winding spiral edge called thread. A screw looks like a nail with grooves cut spirally into it. A screw is actually an inclined plane wound around a rod. Here is the drawing of the screw. You can see the picture of the screw. Threads are shown over here. The tip of the screw is narrow, sharp and pointed. The head has a narrow slit which is used to turn the screw using a screwdriver. As the screw is forced and rotated into a piece of wood, it travels a longer distance than nail would. Less effort is needed to drive a screw into a block of wood than to drive a nail. Also, because its thread, a screw grips the wood more firmly than a nail. Now we are coming to know about the pulley. So there are two types of pulley. One is a single pulley, another is a single fixed pulley and single movable pulley. Remember, pulley is a wheel or a circular disc that can rotate freely about a fixed point. So here is the picture of single fixed pulley. There are different parts, you can see these are all visible, so you must learn them and draw them, because sometimes in the exam the drawing of the pulley, single fixed pulley, comes with the different labelings. This is the single movable pulley. You can see it is used mainly in the factories where the heavy objects are being lifted. So in a single movable pulley, the axis of the rotation is not fixed. Now we are talking about the wheel and the axle. The wheel and the axle. A wheel and axle arrangement consists of a wheel attached to a rod called axle, such that when the wheel is made to rotate, the axle also rotates. These are the different parts of the wheel and axle. Some of the examples of wheel and axles we are showing in our everyday life which come across. So it is better to know about them. A steering wheel, a spindle tap. Machines should be kept in a clean environment which is free from dust and moisture. When not in use, machines should be kept covered to prevent the collection of dust on them. Machines made of iron should be protected from rust by coating them with paint. The moving part of the machine should be regularly oiled with a good quality of machine oil to reduce the friction and the wear and tear. Thank you for watching. Please subscribe this channel for more information and educational videos. Till then, goodbye. See you again. Thank you very much.